Okay, so see the adjacent angles. Okay, so these are the two adjacent angles. Now what we can do, we can add two adjacent angles. Okay, that means I can add these two adjacent angles. I can add angle ABD and angle CBD. Then what will be the answer? What is the resultant angle? So when you add two adjacent angle, just you simply remove their common arm. Simply remove their common arm. Then whatever the angle you can see now in the figure, that is the adjacent angle. That means the angle is now ABC. So if I add two adjacent angles, okay, then the sum is can be obtained like that. Just simply you imagine that this common arm is not there, okay, then whatever the angle is formed after removing the common arm, that is their sum. Okay, so now you see again I draw the common arm. Now ABC is the sum of the two angles, so this bigger angle ABC. Now suppose ABC minus ABD, what will be the answer? From ABC I subtract ABD. Okay, ABC is the bigger angle. In many questions it is done like that. So you just see ABC is the bigger angle. From that I remove one angle. Minus means remove. Which angle I remove? ABD angle I remove. Then just accept the common arm. The non-common arm you remove. Non-common arm you remove. So what we have seen? The angle DBC or CBD, that is the answer. Angle CBD. Okay. So what I want to tell you, that if suppose there are two angles which are adjacent, there are two angles which are adjacent. Now how to add these two angles, how to subtract the angle. So if I add the two smaller angles, the two adjacent angles, then what is the resultant angle? ABD plus CBD, what is the answer? Just you remove, when we add, just you remove their common arm. Okay, answer is ABC. Next, from one of the so if you subtract one of the angle, that means suppose from ABC if you subtract one of the angle, say angle ABD or angle CBD, if I subtract, then you remove the non-common arm. Whatever left, that is the answer. Okay. Now next thing is there. Next, see here. Now we are going to draw two adjacent angles like this. Two adjacent angles, they are like this one, like this. These are two adjacent angles. Okay, clear? So what are the name of these two adjacent angles? Suppose name of these two adjacent angle is say A, B, like that. Okay, so two adjacent angles you can see here. What are the two adjacent angle? One is angle ACD, one is angle BCD. Common letter CD, common vertex C, common arm CD here. If I add these two adjacent angles, what will be my answer? I told you that when you add two adjacent angles, thus you remove the common arm. If I remove the common arm, my answer is what? ACB. Okay, again I draw this one, ACB. Okay, now this pair of adjacent angle was such that the non-common arm, that is AC and CB, they form a line. They form a line. Okay, or you can say that there is a line, already a line was there AB, a point was there on the line C, and on the point a ray was standing, that is CD. A ray is standing at a point on the line. As a result, these two adjacent angles is formed. Okay, you can say like this also. These two adjacent angles are such that their non-common arm form a line, or these two adjacent angles form as a result when a ray stands on a line. Okay, now I add it, and the answer is what? ACB, the straight line. Straight line means what? What is the value of this? 180 degree. So if sum of two adjacent angle is 180 degree, if the non-common arm of two adjacent angle form a line, or if a ray is standing on a line, then whatever the two angles are formed, they are called as linear pair. Linear pair. Okay, linear pair means two adjacent angles if their sum is 180 degree, or you can define in this way also: two adjacent angles where common arms form a line, or two adjacent angle which is formed when a ray is standing on a line. Okay, clear? So based on this, you see, based on this you may have different question. What type of different question? Say suppose one angle is given, you find the other angle, or suppose the ratio between two angles are given, then you find the angle. Okay, or suppose the angles are given in terms of variables, say x, twice x, like that, you find x. This type of question may be given from this one. Next one is there, that is, you see, suppose we consider a line, okay, say line is AB, there is a point, say O. At point O, some rays are standing on the line AB at point O. Okay, so let us consider three rays are standing, say OC is a ray, OD is a ray, and OE is a ray. These are three rays standing at point O on the line AB. As a result, you see, we have got some angles. If I name the angle like that, say angle 1, angle 2, angle 3, angle 4, these four angles are formed on the line. Okay, these four angles are formed. Now, you see, all these rays which are standing on line AB, they are above the line. That means they are on the same side of the line. And because of these rays standing on the line, four angles are formed on the line. Okay, clear? Now, out of these four angles, if I see angle 1 and angle 2, angle 1 means angle BOC, angle 2 means angle COD. So these two angles, you see, they have same middle letter, same vertex, and one common side OC, one common arm. So they are adjacent angles, so we can add them. Okay. Next, if you see angle 3 and angle 4, okay, angle C and angle 4, angle 3 means, I am talking about angle DOE, okay, and it is angle EOA or AOE, like that one. They are also adjacent angles. So what is the sum of angle 1 and angle 2? I told you that you remove the common arm. If you remove the common arm, then you have angle BOD. Okay, your answer is angle BOD. What is the sum of angle 3 and angle 4? Angle 3 and angle 4, they are adjacent angle because same vertex and one common arm. When we add it, what you will get? You remove the common arm, the same, you remove the arm. What I have here, angle DOA or angle AOD. Okay, AOD. So I have, after adding, I have these two angles. Okay, clear? Now, if I add all these four angles, say what will happen? That means if I add BOC, COD, okay, DOE, EOA, all the angles if I add, that means if I add the left hand side, then I have to add the right hand side also. I have to add BOD and AOD also. What is the sum of BOD and AOD? Again, you remove their common arm, you get the straight line AB. What is the value of the straight line AB? Straight line AB is 180 degree. Okay, that means what I have seen here, when these rays were standing on the line, then four angles are formed, and sum of these four angles is equal to 180 degree. So this is also a figure, a property is used in maximum of the question. So in this figure, what you have seen, that there is a line. On the line there is a point. At that point some rays are standing. I have taken here 3 rays. It may be 2 rays, 4 rays, any number of rays. Okay, but all these rays are on the same side of the line. In my figure they are above the line. So whatever the angles they form, sum of all those angles is equal to 180 degree. Okay, it is also a property used here in this question. Next thing is that, which is used in this chapter, lines and angles. That is, next one is, say suppose two lines or line segments, say AB and say CD, they intersect each other at point O. Two lines, or it may be line segment, intersect each other at point O. So when they intersect each other at point O, then in the figure you can see four angles, if I name them like that, four angles are formed. Out of these four angles, if I see angle 1 and angle 3, angle 1 and angle 3, you see their vertex is common. This is the common vertex O. All of them have the same vertex. I am talking about this angle. Angle 3, that means angle AOC. Okay, and angle 1, angle BOD. Angle BOD. These two angles. These two angles have the same vertex, but they are on opposite side of the vertex. If one is on the left side, one is on the right side, like that one. Okay. Similarly, if I see this angle and this angle, that means if I see angle 2, that is angle AOD, and angle BOC, if I see this angle, these two angles also have the same vertex O, and they are on opposite side. Okay, one is above vertex, one is below the vertex. That means these two pairs of angles which are formed as a result of intersection of two lines or two segments, they are such that they have common vertex, but they are on opposite side of the vertex. So they are called as vertically opposite. They are called as vertically opposite. Okay, vertically opposite angles. They are called as vertically opposite angles. So when vertically opposite angles form, if two lines or line segment intersect each other, so in your question, if you see or if it is given that two lines or line segments intersecting each other, then this idea should come into your mind that here I can find out vertically opposite angles. Okay, so vertically opposite angle means what? How can I identify the vertically opposite angles? They form at their point of intersection, that is their common vertex, and they are on opposite side of the vertex. If one is on the left side, one is on the right side. If one is above, one is below, like that one. Okay, that is vertically opposite angles. And they have a property. What is the property? Vertically opposite angles are equal. Vertically opposite angles are equal. Okay, this property. So to use this property, vertically opposite angles should be there, and when there will be vertically opposite angle, if the lines or line segment intersect at a point. Okay, but here not only vertically opposite angles, some other angles are formed. Say suppose angle 1 and angle 2, angle 1 and angle 4. So what is the name of these two angles? Angle 1 and angle 2. You see they have one common arm. Common arm means adjacent, and non-common arm OB and OA, they form a line AB. So it is a linear pair. Similarly, angle 2 and angle 3, common arm OA, non-common arm OC and OD form a line. So 2 and 3, they are linear pair. So when two lines intersect each other, okay, at a point, then at the point of intersection, we get 1, 2, 2, 3, 3, 4 and 4, 1. 4 pairs of linear pair, and 1 and 3 and 2 and 4, 2 pairs of vertically opposite angles. Okay, vertically opposite angles equal, and what is the property of linear pair? Their sum is 180 degree. Okay, next one thing is used here, that is, suppose there is an angle is already there. There is an angle, say name of the angle is AOB. Okay, vertex O, OA and OB, they are the arms. Now same from the same vertex, okay, there is another ray, suppose OC. Okay, when you draw OC, what happened? That the angle, the given angle AOB is now divided into two equal angles. Suppose OC divide given angle AOB into two equal parts, then OC is called as angle bisector of angle AOB. Okay, angle bisector of OC is angle bisector of angle AOB. It bisects angle AOB. Bisects means it divides two equal angles. So when I draw OC, if the OC is not there, then I have only one angle AOB. Okay, when OC was not there, I have only one angle AOB in the figure. Yes, but when I draw OC, then you see I have two angles now. What are the two angles? One is angle AOC, one is angle AOC, one is angle BOC. Okay, if OC is bisector, that means these two angles are equal, and they are equal to half of the given angle. Why half of the given angle? Because they are one out of the two parts of AOB. So 1 by 2 of angle AOB or half of angle AOB. This is also there in many questions. If ray bisects an angle, so what happens when a ray bisects an angle? Two equal angles are formed, and these two angles are half of your given angle. Okay, so this is in your first exercise. If you see the problems of first exercise, okay, if you see the problems of first exercise, then you can see whatever I have discussed. Okay, whatever I have discussed, adjacent angle, then linear pair, vertically opposite angles, angles standing on a line, okay, bisect, an angle is bisected, okay, by a ray. These type of things are used. Okay, these type of things are used here. So to solve the problems of first exercise of chapter 6, these things if you know beforehand, then you see it will be very easy. When your teacher explains the solutions, you will find it very easy to understand this one. And one more thing here I want to tell you. This is also very common. It is not only for angle, for any quantity. Suppose you know the ratio of two quantities. Yeah. Say suppose there are two quantities A and B. Two quantities are there, A and B. Okay. You know that their ratio is, suppose say 2:3. You know their ratio. And you know their sum. Say their sum is suppose say 10. Their sum is suppose 10. Okay. Then how to find out them? How to find out A and B? See, A is to B is 2:3 means it is ratio of A and it is ratio of B. So when you find A, you write the ratio of A divided by sum of the ratios 2 and 3. And this figure you multiply with sum of A and B. You multiply sum of A and B. That means it will be 2 by 5 into 10. So my answer will be 4. A will be 4. To find B, same process. Write the ratio of B divided by sum of all the ratios. Okay, 2, 3, if you add then 5. Into sum of the two quantities whose ratio is given. The sum also must be given into 10. So it is 6. Okay, so this type of things, say for example, we have a figure like that. We have a figure like this one. Okay, these are three angles, say X, Y, Z. These are three angles, X, Y, Z. And suppose you know the ratio of X, Y, Z. These ratios are given, suppose X, Y, Z. What are the ratios of X, Y, Z? Say ratio of X, Y, Z is say 3:4:5. Say suppose just an example, 3:4:5. Can I find X, Y, Z? So one thing I know by this one, that this X, Y, Z, just now whatever we have discussed, they are standing on a line. So their sum will be 180 degree. Their sum will be 180 degree. So that means what is given to you? You have given sum of three quantities and ratio of these three quantities. Now how to find out X, how to find out Y, how to find out Z? Very easy. For X, which is the ratio of X? Ratio of X is this one, 3. Ratio of Y is 4. Ratio of Z is 5. So to find X, you write the ratio of X divided by sum of ratios. So 3 plus 4 plus 5, I think answer will be 12. Into sum of the three quantities, 180 degree. To find Y, ratio of Y by sum of ratios into sum of X, Y, Z. Okay. Then to find Z, ratio of Z, sum of ratios into sum of X, Y, Z. In this way, very easily we can find it out. This is also in maximum problems, it is used. Okay. And in your figure, if you observe this type of things, in the diagram or in the figure, let me show you. Suppose there is some diagrams are there, some figures are, some things are there in the figure, okay, A, O, B, C, D, these are there, and you have observed that a box-like structure is there. A box-like structure is there, a square is there. That box means what? That angle is 90 degree. That box is there means this angle BOC. You can name the angle as BOC, or you can name the angle as COB. That angle is 90 degree because this box is there. Okay, this much if you know, then you see your first exercise will be very easy. Okay.